It's a pleasure to be at Hack in the Box again. First of all, I want to thank Dylan and the team for making this possible, even though I'm not with you in person. But today we're going to have some good time investigating Web3 using open source intelligence. So using our best friend Google, we'll try to extract some useful patterns in Web3 business and technology ecosystems. We'll strive to better understand the technology. And then at the end, we'll try to become more mindful of the risks and security best practices. A couple words about myself. So I used to run the research team at Cisco Umbrella. Before that, I was the first senior researcher at OpenDNS before we got acquired by Cisco. Currently, I do independent research on blockchain and security, and then I shared a lot of my work at various conferences like Black Hat, DEF CON, and Hack in the Box. So in the last couple of years, or at least like last year, we've heard a lot of negative news around crypto and blockchain. For instance, there were a couple major collapses last year. The Terra Luna case, which is an algorithmic stablecoin, and then FTX, the number 2 centralized exchange back then. Both of them had some major mismanagement of customer funds, and also some criminal behavior that led to their collapse. But then you had many other companies that were dependent on them in terms of liquidity and lending. For instance, Celsius and Three Arrows Capital. Celsius is a lender. 3AC was a hedge fund. Both of them collapsed and declared bankruptcy when Terra Luna went bad. And then Celsius also had Core Scientific, a mining company that depended on them. Voyager and Genesis depended on 3AC. And then BlockFi also depended on FTX. And we can observe a major contagion effect here that caused a lot of harm to the crypto ecosystem. Despite this, we had some nice news last year with the successful merge of Ethereum. We went from proof of work to proof of stake. And then we also had many banking and financials getting into Web3. For instance, they've been investing in many startups in the Web3 and crypto ecosystem. Also, many mega brands have put money into NFT projects. For instance, Amazon, Coca-Cola, Disney, Netflix, and Nike. And then another useful statistic is that there has been an increase in the number of active developers working on Web3 projects. Last year, or at least like since last year, despite the collapse of crypto valuation by 70%, we had a nice 5% increase in number of developers working on Web3 projects. The idea is that despite the speculation, people are still interested in meeting the philosophy of Web3 and building value with this new set of technologies. So you might ask now, how can we move, or how did we move from the Web 1 to 2 to 3. So in the early days of the internet, we had an information platform. It was mostly websites and search engines. Then we had the social media platforms, and it was mostly read, write, and interactivity. And in the last few years, we had the Web3 movement, which is bringing ownership, or what we call now the ownership economy. How does that work? In fact, Web3 is a stack of protocols that enable fully decentralized applications. Some of the promises that we want to fulfill is that now you own your data, your content, and the platform. You don't have some central authority who can censor you or ban you. You also have a self-sovereign identity. In addition, the payments and currencies are native to the technology itself. And then we have decentralized, permissionless, trustless infrastructures where anyone can join in and leave and participate with created value. And you also are able to compose multiple software Legos to build different applications. If you were to migrate your Web 2 app to Web 3, typically you'll have to move your backend and database into a blockchain, I would say, setup, but you keep your front end. Eventually, if you want to migrate fully, then you'll have to use at least like 4 different services. A node as a service, This is a type of, I would say, online software that will allow you to interact with the blockchain unless you're on your own node. You also have to have a wallet because the wallet will give you your identity, and with it you can sign transactions and commit information to the blockchain. You might also need decentralized storage or indexing and querying services to help you search the blockchain. Let's take a look at the Web3 tech stack. We can either start bottom up or top down. So let's start bottom up. At the bottom, you have the major layer ones, or whatever you've heard of in terms of blockchain. So Bitcoin, Ethereum, Solana, Avalanche, so on and so forth. These are the fundamental building blocks of this entire ecosystem. Then on top of them, if you want to build applications, you'll have to use primitives. So for instance, like we said, we have storage, compute, communication, identity, also security services to protect your code and your protocols. But then we have some of the most useful use cases like the building blocks of DeFi. So borrowing, buying, selling, staking, and insurance. These are the building blocks that allow us to have multiple decentralized finance applications. And then we have analyze, I would say, building blocks, so you can build statistics and figure out if your application is running correctly. On top of that, you have applications. So typically the applications nowadays revolve around entertainment. So we have NFTs, gaming, also streaming and social networks, and the DeFi, obviously, that we mentioned earlier. And then the doors at the top, these are what we mentioned earlier, the wallets and the hosted node providers who allow you to communicate with the blockchain. So the wallets will help you sign the transactions, and that signature will have to communicate with the node provider to commit the information to the blockchain itself. Another trend we can derive from open source intelligence and use in multiple public sources, for example, the releases by VC funds, will tell us I would say the patterns of the top money. Where is it going in terms of investments in startups, not just like speculation and investment in finance. So for instance, Andreessen Horowitz have been putting a lot of money into layer ones. For instance, we notice Aptos, Linera, and Mistin Labs Sui. These are three projects that came out of the Libra Facebook project. Andreessen Horowitz also put a lot of money into gaming and NFTs, so entertainment, and a few other analytics companies as well. Coinbase Ventures happens to be another major investor in startups working in the crypto space. As we can see here, they bet on infrastructure, Aptos, in addition to A16Z. They also have the same approach where they invest in NFT gaming, metaverse, and DeFi. A very useful source I've been using is CB Insight State of the Blockchain reports. So they release one each quarter. And in the last one, they showed some interesting, I would say, trends. So if we pick up the top funds that raised more than 60, if we pick up the startups that raised more than $60 million in terms of fundraisers, we'll notice 50% of them went to layer ones. So the Mistin, Aptos, Velas, and Fire. They're all scalable blockchains. We also have investments in gaming and metaverse, and then security. Well, if we go back and think again, in fact, a lot of these layer ones that we mentioned, they're trying to solve this, I would say, a tough trilemma, because Ethereum and Bitcoin in the early days, they were betting on decentralization. They had thousands or more of validators or miners, and they were also focusing on security. But they were not very scalable because Bitcoin on one hand and Ethereum on the other hand could not commit, I would say, blocks in less than a few seconds or minutes. The current layer ones, in fact, they try to give up on some decentralization to gain into scalability. For a developer, like most of us, we might want to focus on the layer here we see, the developer tools. In fact, if this one becomes more and more mature, we'll have a lot more adoption with developers moving from Web 2 to Web 3, so we can build more useful applications and build value in this ecosystem. Now let's dive into the technology of Ethereum. So Ethereum, it's a blockchain. It's a chain of blocks. In fact, it's a public append-only decentralized data structure. In it, there's also a global state machine that is captured in the blocks. And then there's a copy of this blockchain that lives on each node that participates in the network. So it's a clone on each one of the nodes. And then the transactions that we commit to the blockchain will trigger changes of the state. And then we have a consensus layer that will allow multiple parties that don't trust each other to reach a final decision together. If we look at the stack, from the bottom we have the network layer, because these nodes have to discover each other, and then they have to propagate information between each other. On top of it, we'll have the consensus layer. Initially, it was a proof of work. Now it's proof of stake. And then we'll have the data layer, which consists in the blocks themselves that have the transactions inside them. And then the application layer, that one is revolves around the execution of the business logic. So we have the EVM, inside which we execute the smart contracts, and these smart contracts are interactive between the accounts. If we want to go and explore the decentralized applications on Ethereum, we'll count, I would say, 4,000 or more. So DApp Radar allows us to, I would say, track most of them. It's a very useful public source. I recommend you check. And then DApp Review is another very valuable public source for anybody who is interested in tracking the top dApps. In this case, we see that most of them are DeFi, so exchanges and lending and borrowing applications. How about the network layer of Ethereum? So if you want to become part of the network, you can actually buy a box if you have a few $1,000s and participate in the security of the network, because you'll become either a miner in the older version or a validator with the current version. Now, if we use the OSINT approach, we can use multiple sources that are available for anybody to check. So Etherscan has a node tracker to tell us about the health of the network. We'll realize actually that more than 50% of the Ethereum network is stored on two hosting companies, Hetzner and Amazon. Well, that begs the question, is Ethereum really decentralized? In fact, last year there were some controversies around Ethereum being threatened to be shut down by Hetzner because they had around 10% of the nodes on their platform or infrastructure. In the case of Solana, in fact, they lost 1,000 nodes or validators that went offline when Hetzner decided to block them because of some pressure. If we look into other blockchains, Avalanche, for instance, has around 1,200 validators. It's a lot less, I would say, decentralized than Ethereum. Still better than Binance Smart Chain, which has only 29 validators. So with all of these layer ones, you can see the trade-offs that are taken in terms of decentralization to gain in, I would say, throughput and scalability. Let's go back and understand some of the main components of Ethereum. So again, using some of the public academic papers, we can see, as I said earlier, that Ethereum, it's a chain of blocks. So we have a block linked to the previous one, and so on and so forth. And in each block, you have the header, which has some useful metadata, and then the set of transactions. So in the case of a transaction, you'll have multiple fields that we'll explore in a second. The other important concept we have to understand is the concept of accounts. So in the case of accounts, we have two types. We have the externally owned accounts that are controlled by an entity, usually a person, that holds a private key. And an externally owned account does not have code to execute. On the other hand, we have contract accounts. These are the smart contracts, and these have both storage and code because they will be executing business logic on top of the EVM. And I invite you to check those two open references that I put there to learn more about the differences. If we go to Etherscan again, our favorite OSINT tool, we can check the top ETH accounts in terms of holding. So there are a few exchanges here. We have Binance, Kraken, and Bitfinex, who own most of the ETH in circulation. We also have the Beacon Deposit contract, which is the contract that guarantees the proof of stake of Ethereum. If we want to describe smart contracts a little bit more, we will go back and say that it's represented by code and storage. It's executed on the EVM. And then typically, if you want to become a developer, you have to write it in Solidity most of the time and then compile it into bytecode and then deploy it on the blockchain to be run on the EVM. And these smart contracts most of the time will be defining the logic of DeFi, NFTs, gaming, and a variety of different use cases. There's a new, I would say, standard that came out lately, ERC 4337, or account abstraction. This one is trying to solve some of the flaws of the EOA, because in the case of an externally owned account, you have to keep the keys very close to your heart. If you lose them, you lose your funds, and if it gets stolen from you, then someone will steal your money and you're gone. So in the case of ERC 4337, now as a user, you can have a smart contract wallet, which can give you a lot more security. And then if you lose your keys, we have ways to recover your accounts with the help of other entities. I invite you to check the standard on this reference here, because I believe it's going to have a lot more applications in future dApps. Now, transactions, another major building block of Ethereum. So we count 3 types. In fact, there are 6 different possible interactions with these 3 types. So we have the EOA, as I said earlier, and the smart contracts, as we see on the figure. So we can have EOA sending money to each other. That's the transfer ETH, as we see it here. We can have an EOA creating a smart contract with this action here, deploy contract. We can have an EOA invoking logic from a smart contract with this arrow here. We can also have a smart contract calling the logic from another smart contract as a helper. That's the case here. This is what we call internal transactions. And then we can also have a smart contract transferring Ether to another smart contract to follow a certain business logic. That's also an internal transaction. And then finally, a smart contract can also transfer ETH to an EOA. Let's say if you have a smart contract that is implementing a payment logic of a business, then let's say every month, the smart contract will transfer the salary of a person to their respective EOA account. So this way we can see that we have multiple combinations and they represent all of the possible cases of smart contracts and EOAs. Now, if you look into the fields of a transaction, the most important ones are the nonce. This is a counter that gets incremented every time the account sends a new transaction. We also have the gas price and gas limit. These are basically, so the gas limit is the amount of, I would say, execution fuel you're allowing this transaction to use, and the gas price is the amount you're willing to pay per unit. The 2 is important, that's the destination. The value is how much money you're trying to send. VRS are useful for defining the source. And then init or data is typically used when you're creating a smart contract because you'll put the code in that field. Now let's look at a few different transactions. So we have transfer of funds, we have the from, the to, and this is typically sending ETH to another EOA. We have an EOA, an externally owned account creating a smart contract. There's the to, which is here the created contract. In fact, sent to a null address, but then after that we have the created contract. And then the input will be the typical code that you compiled from your Solidity into bytecode. You have to submit it in the transaction. Another transaction type is when you call a function from an EOA and you're calling a function of a smart contract. In the input data, you'll be defining the function you're calling of your destination smart contract. The life cycle of a transaction looks like this. So you submit it to the mempool, and then a validator will pick it up, and then it will add it to a block, and then the block will get validated, and then if all goes well, it's added to the blockchain. The Ethereum virtual machine, as we mentioned, is the one that executes these smart contracts code, and it has to have that gas cost and max transaction fees to prevent infinite execution and DDoS. As we said, lately we moved to the proof of stake. In this case, we don't have mining anymore, we have validation. So a validator has to stake 32 ETH into the deposit contract, and that way they can become a participant in the security of the Ethereum blockchain. In fact, we can check on Etherscan, our favorite OSINT tool again, the top depositors in the Beacon smart contract, and we can see there are a lot of staking pools and exchanges participating in the security of Ethereum. If we go back to the top ETH holders, we can see again the Beacon deposit contract is the one that holds the most. Again, we're using most of the Ethereum in circulation to secure Ethereum itself. Makes sense. How about the data model? So initially we said, well, if you want to use the blockchain, you want to use your own node. That's when you have the read-write and all of the authority. If not, you can use some of those node as a service providers I mentioned earlier, Infura, Alchemy, and so on. Or you could just use some other tools like Dune. In this case, they will present the data into a SQL database or graph database, and that will give you a lot more, I would say, options to play with the data, and without having to deal with the overhead. In fact, when we take the raw blockchain data, now we can represent it as a SQL database with multiple tables, so blocks, transactions, contract, and so on and so forth. And with Dune Analytics, which is, I would say, a dashboard and a SQL console, you can run queries and interact with the blockchain and learn a lot about what's going on under the hood. So in this case, we were able to run a few queries, and we are able to see the number of blocks so far since the inception of Ethereum, 17 million. We know there are 1.9 billion transactions so far, 2.7 billion logs, and 6 billion traces at the moment. Now, I'm sure you've heard about tokens. In fact, tokens are ERC20 entities, and the ERC20 standard defines an interface, so it's defining a bunch of functions that you're supposed to implement to make sure the functionality is recognized by wallets and other dApps. In this case, you can have the total supply function that will give back the total supply of that token, balance of a certain owner, so you know how much of this token they own. Allowance, this one gives you, with this allowance function, you give someone else the right or the authority to consume or spend some of your funds in your account. And then you have transfer, which is also useful to transfer funds between accounts. Again, going back to our favorite tool, Etherscan, we can track the top tokens. We notice here most of them are stable coins, like USDT, USDC. In fact, many people work in the crypto space. They get paid in stable coins. And then if we want to move forward, now we can talk about the NFT standard or the ERC 721 standard, or non-fungible tokens. So the difference with fungible tokens in the case of ERC20, an ERC20 fungible token, when you have a unit, it's the same as any other unit. So they are interchangeable. In the case of NFTs, non-fungible tokens, every unit is unique because it has its specific features and characteristics. In fact, it has its unique owner, and you can also get the balance of a certain owner of that NFT. And then you can also have the same functions we saw earlier, the transfer, the approve, and so on and so forth. If you want to track the top NFTs, you realize some of the famous names like Bored Ape Yacht Club and Mutant Ape Yacht Club. This is useful to see the top, I would say, traded NFT collections if you're getting into that game. CryptoSlam is another useful dashboard that gives you a lot of this information for traders and investors and speculators, or even just like hobbyists. And then DApp Radar, our favorite tool as well. It shows us that CryptoPunks is still one of the top traded collections out there. Another interesting, I would say, OSINT exercise is to go and study the celebrities and what they own in terms of NFTs. So, for instance, here we can see that Snoop Dogg has almost $3 million worth of NFTs. Then we have Mark Cuban has 700 grand, Justin Bieber 600, Neymar, your favorite Brazilian footballer 600. So this is very interesting because you'll see later that this has been abused by scammers and spammers. So Gary Vaynerchuk is like a famous influencer. And what happened is that earlier of last year, his wallet was spammed by a massive amount of fake NFTs. So what these scammers do, they will create a replica NFT of a famous collection, like in this case, something looking like the Bored Ape Yacht Club, and then they will spam all of the celebrities' wallets with this token or NFT, so that it looks on marketplaces, NFT marketplaces, as if they were popular and bought by the top, I would say, NFT holders. What that means is that for a naive new trader, when they go and check OpenSea and they see, oh, this new collection is owned by Logan Paul, Snoop Dogg, and Neymar, then I should buy it. And then it's going to go to the moon, and then I'm going to make money. In fact, when these, I would say, naive people start buying these collections, the scammers or criminals, they dump them, and then they will cash out, and all of those poor people, they end up losing their shirt. So this has been like a very interesting MO that affected many of the top NFT holders. In fact, here you see these are some of the addresses, and they had multiple $1 million worth of NFTs, and they were subject to this scam campaign. Now, let's talk about another important aspect of Web3, which is cross-chain bridges. So bridges are important. They are basically smart contracts that are deployed to allow us to communicate between different blockchains. So we see today that we are in a multi-chain world because as different teams and I would say groups or startups try to play with those three pillars of the trilemma, decentralization, security, and scalability, each one of them will take different trade-offs. And therefore, you have multiple chains, and they are not easy to communicate with or between. In fact, we can see that we have many bridges out there trying to solve this problem of interoperability between blockchains. And you might ask, okay, in fact, why do we need bridges? In fact, as I said earlier, we need them to make it a lot easier to transfer assets, for example, tokens or NFTs, but also information, because sometimes you might have a certain useful business logic on one blockchain and it's not available on the blockchain where you're doing your native work. So then you might want to invoke that service across chains and get the result into your own chain. And for that, you might use a bridge. Another useful use case is actually to lower gas fees and have a faster throughput. Like I said earlier, you might have a slow blockchain and a fast one, and you want to have different ways to take advantage of the different features of these blockchains. These bridges, in fact, they come in different flavors. So the most popular one is the lock-in mint. As we can see here, let's say you're moving from Ethereum to another blockchain, and you have a certain amount of liquidity. Well, what you do, you'll bring the liquidity on one side of the bridge. You will lock it, meaning it will become now locked. You cannot use it anymore. But then we will grant you the same value in the different token on the other blockchain, on the other side. And now you can go do your job, like trading or whatnot, on chain B, using this new token of the chain B. The other type of bridges is when you burn and mint, meaning you will lose or destroy the liquidity on chain A, but then you will get the equivalent on chain B, and then do whatever you want to do. Another type of bridges is the atomic swaps. In this case, you don't lose it on chain A, but you get a completely different set of tokens on chain B to do your bidding. And these have different use cases. In fact, in the case of Ronin ecosystem, for those of you who have been doing gaming, Axie Infinity created like a very popular game in 2021 in Southeast Asia, and a lot of people were playing this game, play to earn, but the liquidity was on Ethereum, so they had to create a bridge to make it possible to buy the tokens of Axie with Ethereum. Well, when they created the Ronin bridge, it was very useful, but then it was very vulnerable. In fact, there was a major hack that happened in 2022, last year, where these hackers were able to steal around $626 million. The attack happened in multiple steps. So initially what you do, you create an address of the attacker, and you will finance it with money because, as we mentioned earlier, if you want to commit transactions to the blockchain, you have to pay fees for the code you'll be running. So first you have to fund your attacker address, and then I'll explain in a second, they were able to compromise 5 out of the 9 validators that Ronin had implemented. So it was a social engineering attack where they were able to get the private keys, and then they were able to do step 2 and 3, which means they transferred a massive amount of money in ETH and USDC into their attacker address. And after that, they were able to launder the money and benefit from their heist. Here we can see how the 5 validators, in fact, were compromised, and they just authorized the transfer, because what happened is that one of the engineers was compromised by the attackers, and they were able to get the keys, and then they authorized the transfer of the funds. A very useful tool actually for OSINT is called breadcrumbs.app. I highly recommend you check it because it can help you see how the funds were moving out of the first attacker address when they were trying to launder it across decentralized exchanges and centralized exchanges. Now, in the case of Ronin, they had just 9 validators to guarantee the security of this bridge and the movement between Ethereum and Axie. Well, 9 is very weak. In fact, only 5 were necessary or enough to authorize transactions. Well, today they tried to do better and they moved to 22, so they doubled practically the number of validators. Is that enough? Open question. And I hope they learned their lesson. And this is not bashing on this team, it's just a matter of trade-off, like we said, between decentralization, security, and scalability. Now, let's talk a little bit about Web3 attacks. So if we go back and study some of the open source work describing a lot of these attacks, we realize that a lot of them are actually Web2 attacks, meaning in this case of the Ronin bridge, the private keys were stolen. And in a lot of other cases, actually, it was also like phishing and social engineering that led the victim to give up their keys without knowing, and the attacker was able to validate the transactions and steal the funds. The other types of attacks we noticed were vulnerabilities in the smart contract itself. And that's the case of Poly Network, Wormhole, and a few others. A very useful OSINT tool, I would say, or website I recommend you check out is erect.news. So they have a leaderboard that helps you check the top hacks that happened recently. So Ronin is still number 1 so far, and a few others are coming up every once in a while, unfortunately. Now, DeFi Llama is a very useful, I would say, dashboard that helps you see the different attacks or hacks that happened recently. As we can see here, as of a few days ago, on April 15th, there was a hack worth $7 million on the 100 Finance protocol. And then many flash loan attacks happen every once in a while, worth a few $1 million. And collectively, we can see that there has been $6.4 billion so far of stolen funds across all of these hacks. That's a massive number, in fact. Now with DeFi Llama, we can also sort by the amount lost. So we recognize Ronin again at the top. And what we like here is that the DeFi Llama dashboard puts the classification and technique. So we can see here that there are different classes. We have the infrastructure attacks or class of attacks. We have the protocol logic type of attacks. And then sometimes they also have the ecosystem attack. And in each one of them, you have the technique. So in the case of Ronin, as we explained, we have a private key compromised with social engineering. In the protocol logic, we have an access control exploit. For example, here, if you have a certain entity not allowed to do a certain call a certain function, and yet they were given that right or that control by exploiting a vulnerability in the code. Now, looking into three different references, I concocted these three taxonomies to understand a little bit better the ecosystem of Web3 attacks. So, taxonomy 1 breaks them into three types. The first class of attacks, I would say, is the compromised private keys, where, as we saw in the Ronin case, the keys were stolen, and then with that, the attackers were able to authorize the transfer of funds fraudulently. We then have phishing and social engineering attacks, typical Web2 attacks as we know them. And then we have the smart contract vulnerabilities. These are inherent to the Web3 ecosystem. In the case of the smart contract vulnerabilities, we can break them using the taxonomy number 2 into code exploits or economic exploits. So in the case of code exploits, this is again a flaw in the coding, the way you implemented your design. So, for example, back in the day, we had the buffer overflow and stack overflow attacks in C and other languages. Same thing here, you might fall into the entrancy attack case, or you might have the overflow and underflow attacks, or others where you were not careful writing your code. The other types of attacks are the economic exploits. In this case, you will take advantage of some flaw in the design of the incentive mechanism or the way the governance is implemented in your protocol. In fact, if we go and look into the taxonomy number 3, we'll see the governance attack. In this case, for Beanstalk, for instance, in a nutshell, what happened is that the attacker was able to take advantage of a vulnerability to grant himself a massive amount of tokens, and those tokens allowed him to gain a lot more authority to vote on a change in the protocol, and that change simply consisted in giving himself most of the liquidity in the protocol. So he basically voted for himself to become rich and steal all the money. The other attacks we saw are supply chain vulnerabilities. This is typically when you are using other libraries and providers. So you have to make sure they're not vulnerable and you're not depending on their flaws, because if they're broken, then your entire system will be broken as well. We also have the other types of attacks, as we call them oracle attacks. In this case, oracles, to describe them in a nutshell, these are software, because on the blockchain you don't have, for example, information like pricing and weather and other entities that are coming from the real world. So when you need off-chain information, you will use an oracle. In this case, if you are implementing a certain business logic on the blockchain using some pricing information, and the oracle is giving you that information, well, if we compromise the information coming from the oracle, then we can, for instance, buy a token for cheap, because the oracle now is telling me it's a lot cheaper, even though it's expensive. And then once I get them for cheap, I can go sell them back to whoever is out there, because they will see the real price. And that way, I will make a lot of money fraudulently. And then we also see some other types of attacks. These are like new vulnerabilities that are typically, I would say, unknown, and we have to implement new countermeasures. Another way to look at these different attacks is by, if we try to abstract away the different steps, we realize we can implement the cyber kill chain that comes from Web 2. So in the case of Web 3, it's a little bit different, because we start with funding. As we saw earlier with Ronin, you have to transfer funds into your attacker wallets, because you'll be able that way to pay for the gas fees of the fraudulent transaction. After that, you prepare your attack. So, for example, if you're trying to exploit a reentrancy attack, you'll implement a malicious smart contract. Or if you're trying to compromise keys or make someone with authority accept something or do an action that they don't want to do, but you make them do, you might lure them with some phishing attack or social engineering. And then comes step 3, which is the exploitation. This is basically when you compromised the victim, and now you're able to steal the funds by validating the fraudulent transactions with the private keys. And finally, once you have the money stolen, you stored it in your exploiter or attacker address or wallet. Now you have to take advantage of your heist money. So you'll have to launder it somehow. And in this case, you might use centralized exchanges. In the past, the exchanges that have been subject to abuse were Binance, Kraken, and Coinbase. But then with the work with the government and many other analytics companies, they had to crack down on a lot of these accounts that were being used for laundering money on their platforms. Then you had hackers or attackers move into decentralized entities. For example, Tornado Cash that was shut down last year was heavily abused to launder money coming from these types of attacks. You might say, okay, with all of these attacks, what is the community doing? In fact, there's a lot of work, and many companies and tools are being implemented and run, so we can realize that we have some focus on the smart contract and protocol logic. We have a lot of work being done on the infrastructure, for example, on the wallet security. We have the auditing services, security testing tools, bug bounties, formal verification. And then we also have a lot of, or I would say many companies working in the threat intelligence and blockchain forensics ecosystem. In fact, government entities buy a lot of these products to help them do the AML, KYC, CFT work to counter the financing of terrorism and anti-money laundering. So the ecosystem is actually quite thriving, and I invite you to check this open resource from Coinbase Ventures to see where you might be able to build some tools or create some value. I guess to wrap up, some best practices to implement in Web3 security. So typically we distinguish between pre-deployment and post-deployment. So in the pre-deployment, we're talking about prevention. So you're applying your typical SDLC, so software development in a secure way. You should do your threat modeling, meaning know your attack surface, the vulnerable parts of your system, and then the potential attackers and what type of means they have at their disposal to attack you. Make sure you use some audited code libraries. Smart contract audit is also important. And then also audit your supply chain. So same way when you use like other libraries, make sure your providers are also secure and well vetted. The testing, of course, and then attack simulation. So this brings us back to all of the red teaming and blue teaming to test the, I would say, viability of your infrastructure and software. Then you have another important aspect, which is the policy enforcement. In this case, identity verification. So not anybody is allowed to, let's say, access your keys or access your code or modify your smart contract. Enforce that with access control. And you can also do it with asset segregation. For instance, a lot of these centralized exchanges, they keep a small amount of the liquidity in hot wallets, meaning like online, and then 95% of their money is put in cold storage, meaning it's not connected to the internet, so it cannot be hacked or compromised and stolen. This is the case of the top exchanges, in fact. So most DeFi and Web3 protocols should implement this same approach. Then we have post-deployment. In this case, we distinguish between detection and response, meaning as the Web3 project is living, we try to detect these suspicious or malicious actions on the fly. So we'll have transaction monitoring and reputation score on these transactions. If we detect something suspicious, we can front-run the exploits, meaning we'll try to submit a transaction with a higher gas fee, meaning we're willing to pay a lot more money to make our transaction override the hacker's transaction and then take the money from the vulnerable accounts or smart contract and put it in our own account. We are white hat hackers, and then give it back to the victim later on. Or you could do automatic pause, meaning like you'll stop the functioning of the smart contract while waiting to fix it. There's also wallet tracing, because you could either monitor transactions or wallets if they have certain suspicious behavior. Finally, unfortunately, if the harm happened and you're just responding and being reactive, sometimes you're able to roll back transactions Not possible all the time though. Or you'll just have to do your DFIR work and try to recover what's recoverable, learn from your mistakes, and then implement a more, I would say, reliable and a viable approach to security for next time. Cyber insurance is also another possibility, but then again, this is a reactive approach in case the harm occurred. Some of the final thoughts. As we can see, there's a lot of hard work to be done to live up to the promise of Web3. There's a scalability issue here. We have to scale the layer ones so we can implement a lot of the, I would say, primitives and dApps on top. Because if we don't have scalability, then only the, I would say, the believers or the firm believers will keep using the Web3 ecosystem or applications, and we don't have any of the non-believers be convinced to join this movement. So you have to have a better user experience, and that comes with, I would say, scalability, low latency, and higher throughput to have a quicker response. Then it's important to find real problems actually to solve with the Web3 ethos. So we're seeing mostly entertainment, gaming, and NFTs nowadays. Well, they have a lot of use cases, but then can we solve some of the more, I would say, pressing problems we face in this world? For example, banking the unbanked, helping communities with funding and capital to build businesses and help each other. And then one final thought is around like the development tools. We believe they should become a lot more mature if we want them to be easier for Web2 developers to join the Web3 movement. And application developers will get more creative and can focus on business logic if, as we say here, the infrastructure layer becomes more mature. So in a sense, what I wanted to do with this talk is share with you a lot of the open source intelligence resources I went through myself. So it was a mix of academic papers, online free tools, research reports from investment firms, and articles and blogs. And as you can see, you can build quite a good, I would say, grasp of the ecosystem from a business perspective and a technological perspective. And then you might decide to join the movement and start creating value either in security, like in our case, since we are in Hack in the Box, or maybe build other value with other applications. Some resources I believe are also worth mentioning. So web3edge.io is a very good site with a lot of very valuable technical information. And then forta.org, they have a very good blog with a lot of work in security and transaction monitoring. Thank you so much. I hope this was useful. And I hope to get some questions maybe online or in the comments. Thank you.